Hi everybody, today we're going to learn how to write a lab report in Honors Chem. The lab reports in this class are going to look a little bit different from lab reports you've written for other science classes. The lab report needs to be a professional document. It should be typed. If you run out of ink or your printer's not working or something like that, every now and then I'll accept it handwritten, but make sure that it is very neat and easy to read. You can handwrite different equations or calculations or graphs or things like that are hard to type up, but the majority of the lab report should be typed. If you do choose to write something out, it needs to be in blue or black ink, so no pencil, no turquoise ink, no pink ink, nothing like that. And again, the exception to that is graphs and calculations can be in pencil. Your lab report should also be in passive voice and past tense. So it has to be past tense because you're writing about a lab that has already been done. And it needs to be passive voice because in the science community, what we care about is the actual lab or, in a real lab facility, the research itself, not what the group or the scientist or whoever did the lab, did. So it should be in passive voice. So, for example, you don't say, I masked a sample of zinc. You don't say, the group masked a sample of zinc. You say, a sample of zinc was masked. So a sample of zinc was masked would be passive voice. Each lab report will look slightly different. On the handout, I will tell you what parts of a lab report I need, but these are the general parts of a lab report, and we'll go through each one of them. So the first one is heading. I almost always have to have a heading. The heading should include the title of the lab, the date the lab was performed, so not the date that the lab report is due, but the date that you actually went into the lab and did it, your name, your partner's name, if applicable, and your lab station number. Between your name and your lab partner's name, make sure that you distinguish between the two, so when I look at your lab report, I know who wrote it. It shouldn't be just two names. So maybe write partner and then write their name, so I know. And then the lab station number, that's the number on your cabinet. So for each of these parts, if you look at the next 2 pages, you will find some good samples and bad samples. So let's start with the heading here. So a good heading, here you have the title of the lab, you have the person's name, you have the partner, and I can tell who wrote it and who's the partner, the date the lab was performed, and then also the lab station number. This is a bad heading, not because it's all in one line. That is fine if you do it all in one line, but because I can't tell who is the person who wrote it because there's 2 names there. So that would be the bad part. I would also separate the title of the lab, on the next line or something like that. All right, so that was the heading. Let's take a look at the next part. The next part is the purpose. So the purpose, you write the word purpose, and then semicolon, then you say what was or were the objectives of the lab. The purpose should only be 1 to 2 sentences maximum. So let's look at good purpose. So if you look at this one, it says purpose, semicolon, to determine the empirical formula of a compound of combining weights. A bad purpose is, in this lab, the class will calculate the empirical formula of a compound. We will determine it by taking first the mass of the compound, then combusting it, then remassing. So this is a really bad purpose. First of all, you're using personal pronouns. You can never do that. It is not in passive voice. And also because it's really, really long. It's talking about procedure in there, which you don't want. All right, next section is procedure. Procedure could be the easiest part of the lab report or it could be the hardest part of the lab report. So the procedure is a brief description of what was done in the lab in passive voice without any personal pronouns, so no me, I, we, the group, any of that stuff. And it should be in past tense, and it should be bulleted or in numbered steps. and you do not want to write any steps for analysis or calculations. If you are given a handout with specific procedures, you may write just see handout. So let's take a look at some good and bad procedure. So this is a good lab procedure if I gave you a handout that has the procedure written on it. All you write is procedure, semicolon, see handout, period. Notice grammar counts for the whole entire lab report, spelling counts, punctuation counts, so make sure the first letter of your sentence is capitalized, at the end you have a period, your spelling is good, all that stuff. This one's bad because there's no period and the H there is capitalized for no reason. You would actually lose points for that. Now, what if I don't give you the procedure on the handout? So here's a good one. It's numbered. It is in passive voice and past tense, so let's read it together. A saturated solution of calcium iodate was prepared by combining 20 milliliters of 1 molar calcium nitrate with 50 milliliters of 0.2 molar potassium iodate until a white precipitate is observed. A gravity filtration was performed to isolate the solid obtained in step 1. The white solid was washed with water 3 times, dried, and masked. So it's concise, it's in passive voice, what was done to the substance, not what you did. There are periods, punctuation and grammar are correct, spelling is correct, all that is great. Let's look at a bad procedure. So it says measure 20 milliliters of 1 molar calcium iodate. That's bad because it's an order. It should be in passive voice and past tense, so this would not be okay. You also can't say measured 20 milliliters. That's not a complete sentence. You can't say I measured. You can't say the group measured. None of that is okay. Also remember that you don't include how you calculate stuff or how you analyze the data. So nothing about graphs, nothing about calculations, none of that stuff should be in the procedure. It should be short and sweet. Okay, let's look at the next part. So after the procedure, then you need a data table. So the data collected, including units, should be arranged neatly in a table format. Now, you don't really have to have it in table format. It's preferable because it's easier to see, but it is fine if you just have a list or something like that. Measurements should be recorded with the appropriate significant figures. So once we've learned significant figures, that applies to all of the labs and all of our tests that we take throughout the year. So make sure you record them with correct sig figs and correct units. Just so you know, data tables include any type of data. So it could be quantitative, like numbers and measurements, or it could be qualitative, as in descriptive observations, like a color of a solution, seeing bubbles, odors, smell like stuff like that. So let's take a look at some good data and some bad data. So here's a good one. So you have your data table, you have your units written out, you have the correct number of sig figs, and you have some descriptive observations as well. This one's bad because you can tell that's not the correct sig figs. I know because one of them is, more precise than the other, which, if you're using a balance, it should be the same. Also, there are no units, and also, I don't know what 1 and 2 are. Even if the reactions are numbered in your lab handout, you should explain what number 1 and what number 2 is. So it looks like there are 2 different types of reactions here, and this one is good because it tells you which one you're talking about. Let's go to the next part. So the next part is the results, and if you do need to provide results, it will tell you what I want in the results. So let's read through this quickly together. In this section, you will analyze your data and discuss your results. So that's where you do your calculations or your graphs or your analysis. It says you should explain the theory behind the experiment and the meaning of your results. This section should include calculations, graphs, and charts when applicable. If you do have calculations, your calculations should be labeled. What are you calculating? if, for example, you collected volume and mass and you're calculating density, make sure you write density is equal to mass over volume. So it should be labeled. It should also include any equations that you're using. Your work should be shown with units. And if I give you an accepted value and you are calculating something in the lab, you need percent error. Calculations can be typed, or they can be handwritten in pencil or in blue or black ink. If you have graphs and charts, your axes and points should be labeled. The graph should also be titled. The title of any graph should always be y versus x. And the graphs may be drawn in pencil. Again, you can type them up, like graph them on Excel or something like that, and you could also handwrite them in blue or black ink. So let's take a look at a good sample of results. So this one was mass versus volume to find the density. So let's look over it together. So it says the mass and volume of different samples of substance A were graphed below. So it's telling me what this is. It's telling me because the density is mass per unit volume, I'm using my slope of the graph to get the density. It's showing the calculation for how I got the slope. I'm using the formula rise over run. I'm showing my units in my work and then my units in the final answer. And then it's explaining what my results mean. So in this particular lab, we were trying to find the density in order to identify a metal. And so we got the density, we compared it to some known metals, and we figured out that it's aluminum. And then we calculated the percent error, and here's the equation for percent error, which is the observed value, that's the value you got in your lab, minus the accepted value, that's the literature value, over the accepted value, and then times 100%. So again, I gave the equation, and then I gave my work plugged in with units, and then my answer with the units, which is percent in this case. This one would be bad. One thing that's bad here is that my graph doesn't have a title. I don't have my axes labeled. I also connected my dots or my points as opposed to finding a best fit line. In science, we always find a best fit line, not connect the dots. I don't know what this is. It's not telling me what I'm calculating, that it's slope. It's not giving me units. Same thing with my percent error. It's not telling me that this is percent error, and it's not giving me units here. All right, the last part of the lab report, which is usually by far the hardest part, is the conclusion. So in a conclusion, again, it needs to be correct grammar, correct spelling, all that good stuff. It should be in paragraph form, and you can't use personal pronouns. So again, you don't talk about what you did, you talk about what was done. So there are certain things that you need in a conclusion. Again, sometimes you need all of these things, sometimes some of them are not applicable. So the first thing you want to do is state your overall result. For example, if you were trying to find the density of an object and identify it, then your first statement should be the density of sample A was whatever, and then it was identified as whatever. So look at your purpose, determine what the purpose of the lab is, and answer that. So you should be stating your overall results. Remember, you have to have units there as well. Next, if applicable, state the literature or the accepted value. Sometimes that will be given to you in the lab handout. Sometimes I will tell you what it is in class, and other times I'll tell you, hey, go look it up online. Next, if applicable, state the percent error. The calculation for the percent error should be in the calculations or results portion. But in the conclusion, you just state what the calculated value was. So you show your calculation for percent error in the results, but then you state in the lab report what your percent error was. Next, you need to state a valid source of error consistent with your results. So if your results were higher than they should be, then you need a source of error that makes them higher, not lower. And then you state which measurement was affected by that error and how was it affected. Was it higher or lower than expected? Then you go through the calculations that you used this measurement in, and you tell me which calculations were affected and how were they affected. Were they higher or lower than expected? And then you talk about your overall result. So for example, if the purpose was to calculate the density, and you talk about the density, which is your overall result, again, how was it affected by this error? You do not mention if the lab went well or not, if your results are good or close or any of that stuff. So let's take a look at some good and bad conclusions. So let's look at the first one here. So the goal of this lab was to calculate the percent sugar that was in gum. So your first statement should be, what are your overall results? The percent sugar in double bubble gum was calculated to be 75.2%. That's your first statement. Second, state your accepted value. So the accepted value for the percent sugar was 83%. Next, you state your percent error. Remember, the calculation should be in the results portion, but your stated percent error should be in the conclusion. So the percent error was negative 9.4%. Next, you state a possible source of error that would affect your results. So a possible source of error was that not all of the sugar was removed from the gum when it was chewed. Next, you talk about which measurement was affected. So this error would have caused the mass of the gum after chewing to be higher than expected. Next, you talk about the calculation and how it was affected. So the calculation affected in this case is the difference in the mass of the gum before and after chewing is the mass, which is the mass of the sugar, was lower than expected. And then finally, you talk about the overall result. So my overall result was the percent sugar. And so in this case, it would be lower than expected. So that's a good conclusion. Now let's talk about sources of error. What are okay sources of error and what are not okay sources of error? Let's go back to the first page here. So you may not use these as a source of error. You cannot say it's human error. You can't use the words human error. You can't also describe human error. So you can't say, I didn't follow the directions carefully, or I didn't do something right, or I didn't measure right. You can't blame your teacher either. You can't say, the solution that was prepared by the teacher was impure or something like that. You also can't blame your partner. So you can't blame anybody. No humans should be blamed. You can't blame precision of measuring tools. So you can't say, the balance was not precise or the balance is not calibrated. You can't blame faulty or uncalibrated equipment. You can't say it was measured wrong, because that's blaming you or your partner. You also can't say that you have incorrect calculations or rounding, because that's also blaming you or your partner. That means you can't measure right, or you can't calculate right, or you can't round right. So you can't use any of these as your error. What can you use? You can use things that are unavoidable or extremely hard to avoid. So things that are not your fault. So what are some examples of those? When we were talking about the gum, to get the percent sugar, we chewed the piece of gum. No matter how much you chew it, you can't really get every single molecule of sugar out. So that is an acceptable source of error. Let's say you took out the piece of gum and you're trying to mass it. You can leave it there to dry, but it is really hard for water to dry, and so no matter how long you leave it, you can't get every single molecule of water out of that unless you put it in a drying oven or something like that. So your sample being wet is an acceptable source of error. Let's say you're measuring some hydrochloric acid in a graduated cylinder, and you pour it into the beaker where you're doing your reaction. No matter how much you pour, there will be a little bit of hydrochloric acid left in your graduated cylinder. That's called loss and transfer. So you would say some of the hydrochloric acid was lost and transferred from the graduated cylinder to the beaker. So loss and transfer is an acceptable source of error. You can't really control that, as long as you say from where to where. What you can't say is, you mass something in a weigh boat, and to get it from the weigh boat to your lab station, you can't say it was drafty and you lost some, or you can't say that you spilled some, but you can say there is a source of error because you lost some of your substance in transfer from the weigh boat into your flask or something like that. So it's really hard to come up with appropriate sources of error. If you ever have questions, or you're not sure, or you came up with an idea and you want to check with me, please come see me before the lab report is due, and I'll read it for you and tell you whether it's okay or not. A couple of things to watch out for. Remember that a lab report should be professional. You cannot use any of the words here, so you can't use any personal pronouns, so no I, we, you, me, your, our, any of those. The scientist or the group or his or the teacher. You also can't use the word discovered. We're not really discovering anything in a high school lab. You can't use the word create. The word create is one of my biggest pet peeves. So we cannot create things. Whether you're a science person or you're a religious person, you should never say that you created. If you really like science, matter cannot be created or destroyed. So you can never create anything. Instead, you can say formed, produced, yielded, something like that, but never created. So you never use the word create there. You can't say fact. Nothing in life is really a fact. If you say the sun will rise every day, that's not a fact, because it's, in a few million years, the sun won't be there anymore. So we are limited to our observations, and so we can't really say that anything is a fact for sure. You can't say mess up. You can't say skew, or throw off, or figure out, or find out. Those are all not professional words. You can't say hope. We don't really hope in science. You can't say believe. We don't really believe anything in science. We can't infer. You can't say real. You can't say dump, or piles, or probably, or of course, or obviously, or actually, or whatever. Those sound a little standoffish. You can't use abbreviations. You can't talk about your results, your opinion about your results. So you can't say your results are off, or close, or good, or bad, or inaccurate, or wrong, or strange, or weird, or goofy, or any of these things. Some words to be careful with. Be careful with the word calculate versus determine versus measure versus obtain versus conclude versus take. So use the appropriate word. For example, we don't say we take the mass of my sample. You say the mass was measured. The mass also was not calculated, it was measured. And so be careful with those words. Be careful when we do chemical reactions, equal versus an arrow. Be careful with the words melt versus dissolve versus react. If I put some magnesium in HCl and it looks like it disappeared, it did not melt, it did not dissolve, it reacted. So be careful with the wording there. And then heat versus burn. If you heat up some water, you just boil it, it's still water. But if you burn a piece of paper, then it turns into something completely different. So be careful of those words as well. So look over all of the good and bad examples, come in and ask questions. If you ever have any questions or need any help, please don't hesitate to ask. Good luck writing your lab report.